What if I told you that one of the brightest stars in our night sky, Betelgeuse, might be gearing up for an explosive transformation? That's right. The James Webb Space Telescope has just picked up something absolutely chilling about Betelgeuse, and scientists are left in awe. This red supergiant has been behaving strangely for years, but what we've just learned could change our understanding of stars forever. Stick around as we dive into this mind-blowing discovery and explore what it could mean for our solar neighborhood. Betelgeuse is a red supergiant star located in the Orion constellation, approximately 700 light-years away from Earth. It's about 1,000 times larger than our Sun, and if it were placed in our solar system, its surface would extend beyond Jupiter's orbit. Betelgeuse has been in the spotlight for astronomers due to its impending supernova, a powerful explosion that could happen anytime within the next 100,000 years, a blink of an eye in cosmic terms. Its erratic behavior over the last few years has sparked curiosity, with scientists constantly monitoring its every flicker and pulse. And now, thanks to the James Webb Telescope, we've learned something new and unexpected about this stellar giant. Since late 2019 and early 2020, Betelgeuse experienced a mysterious dimming event that caused its brightness to drop by almost 70%. This baffled astronomers, as no one knew what could have caused such a dramatic change. Some speculated that it was an indication of an imminent supernova, while others believed it could be due to dust clouds or a large sunspot covering the star's surface. The recent data gathered by the James Webb Telescope has now given scientists a much clearer picture of what might be happening inside Betelgeuse. This dimming was likely caused by a massive outburst, where the star ejected a significant portion of its material into space, creating a cloud that blocked its light. The James Webb Telescope, with its advanced infrared capabilities, has just detected something truly extraordinary about Betelgeuse. It appears that the star is cooling down faster than expected. This rapid cooling is a sign that the star is shedding its outer layers at an alarming rate, which could mean that Betelgeuse is closer to exploding into a supernova than previously thought. The data shows that the star's surface has been undergoing violent upheavals, with massive amounts of gas and dust being ejected into space. This unprecedented observation has left scientists scrambling to understand what this means for the future of the star. If Betelgeuse were to explode, it would be one of the most spectacular events ever witnessed by humanity. The supernova would be so bright that it could be visible in broad daylight for weeks, if not months. But don't worry, Betelgeuse is far enough away that the explosion wouldn't pose any threat to Earth. However, it would give scientists a rare opportunity to study a supernova up close, providing invaluable data on how stars live and die. The energy released in such an explosion would also spread elements like carbon, oxygen, and nitrogen throughout space, which are essential for the formation of new stars and planets. The James Webb Telescope's findings on Betelgeuse could have far-reaching implications for the study of stars and their life cycles. Understanding the behavior of Betelgeuse not only helps us predict when it might go supernova, but also gives us insight into the processes that govern other massive stars in our galaxy. This could lead to new discoveries about how stars evolve, how they create and distribute elements across the universe, and even how planets like Earth might form. As we continue to observe Betelgeuse, we are on the brink of unlocking new mysteries of the cosmos, thanks to the incredible capabilities of the James Webb Telescope. Betelgeuse has been a prominent star in human culture for thousands of years. Ancient civilizations, from the Egyptians to the Greeks, observed its brightness and position in the sky, often linking it to mythologies. In many cultures, Betelgeuse was seen as a celestial marker, helping with navigation and timekeeping. Its position in the constellation of Orion also made it a key feature in seasonal star maps. But beyond its cultural significance, Betelgeuse's dramatic changes in brightness have puzzled astronomers for centuries. With the discovery of its impending supernova, we are now uncovering layers of history tied to this stellar giant. Stars like Betelgeuse undergo massive explosions, because they reach the end of their life cycle. As a red supergiant, Betelgeuse has already burned through its hydrogen fuel and is now fusing heavier elements in its core, such as helium, carbon, and oxygen. Once it reaches iron, the star can no longer sustain nuclear fusion. This triggers a collapse of its core, resulting in an explosion of unimaginable power, a supernova. This process, while violent, is essential for spreading heavy elements throughout the universe, seeding future star systems and planets. If you were able to approach Betelgeuse, you'd see a massive glowing sphere of gas with a surface that's constantly bubbling and shifting. Unlike our Sun, which has a relatively stable surface, Betelgeuse is highly unstable, with frequent eruptions of material into space. Its surface would appear as a chaotic sea of boiling plasma, with bright patches of light marking areas where intense convection occurs. The sheer size of Betelgeuse is also mind-boggling. Its diameter is so vast that it would take light around 14 hours to travel across the star. Though Betelgeuse's supernova would be an incredible spectacle in the sky, it poses no direct threat to Earth. At 700 light-years away, the star is far enough that the harmful radiation from the explosion would be minimal by the time it reaches us. However, it could have some indirect effects, such as increased cosmic rays that might slightly impact our upper atmosphere. But rest assured, any potential effects would be negligible compared to the awe-inspiring light show that would unfold in the sky. When Betelgeuse finally explodes, it will likely become one of the brightest objects in the night sky, even outshining the full moon. For weeks, the supernova will be visible to the naked eye, and for months afterward, it will continue to glow as it fades. In fact, the light from the explosion would be so intense that it could even be seen during the day. Observatories around the world would scramble to capture every moment, offering us unprecedented views of a supernova's aftermath in real time. Although Betelgeuse's recent behavior suggests it's nearing the end of its life, predicting the exact timing of its supernova remains challenging. It could happen tomorrow, or it might not happen for tens of thousands of years. The star's cooling and material ejections suggest it's shedding its outer layers faster than expected, but this doesn't provide a precise timeline. Scientists continue to monitor it closely, hoping to catch signs of an imminent explosion, such as a dramatic increase in brightness or changes in its internal structure. The James Webb Space Telescope, JWST, is uniquely suited to studying stars like Betelgeuse. Unlike its predecessor, Hubble, which focused mainly on visible light, JWST can observe in infrared. This allows it to peer through the clouds of gas and dust that surround Betelgeuse, offering insights into the star's outer layers and the materials it's ejecting. By capturing these details, JWST is helping astronomers understand the life cycles of massive stars and how they end in spectacular explosions. While Betelgeuse is one of the most famous supernova candidates, it's not the only star in our galaxy poised to explode. There are other red supergiants and massive stars nearing the end of their lives, such as Eta Carinae and Antares. However, Betelgeuse's proximity to Earth and its erratic behavior make it a prime candidate for close observation. If it does go supernova, it will provide a model for understanding similar stars in distant galaxies. Stellar evolution refers to the life cycle of stars, from their formation in nebulae to their death as white dwarfs, neutron stars, or black holes. Stars like Betelgeuse represent the final stages of stellar evolution for massive stars. These stars live fast and die young, burning through their fuel in just a few million years compared to smaller stars like our Sun, which live for billions of years. Studying Betelgeuse gives scientists a front-row seat to the last moments of a massive star's life. When stars explode as supernovas, they release an incredible amount of energy, including light across all wavelengths, from gamma rays to radio waves. Astronomers use a variety of telescopes to capture this light and study it in detail. By analyzing the light emitted by Betelgeuse's explosion, scientists can determine the elements created in the explosion, the star's temperature, and how much material was ejected. This data helps refine our understanding of stellar physics and the role of supernovas in the universe. If Betelgeuse were to explode, it could also impact future space missions. Satellites and space telescopes would be adjusted to capture the event, providing valuable data. Space agencies like NASA might also plan new missions to study the remnants of Betelgeuse's supernova in greater detail. These missions could help us learn more about the distribution of elements in space and how supernovas contribute to the formation of planets and stars. Betelgeuse has also made its way into popular culture, featuring in movies, TV shows, and even literature. Its dramatic name and size have made it a favorite subject in science fiction, often depicted as a looming, dying star on the verge of explosion. The star's potential supernova is sometimes used as a plot point in stories about the end of the world or cosmic events that change humanity's future. As we get closer to witnessing this real-life event, Betelgeuse's status in popular culture is only set to grow. Even if Betelgeuse doesn't explode within our lifetimes, its fascinating behavior will continue to provide valuable data for researchers. As new technologies like the James Webb Space Telescope come online, astronomers will be able to study the star in even more detail. We may uncover more surprises about its internal structure, its life cycle, and what triggers such dramatic changes in brightness. These findings could reshape our understanding of not just Betelgeuse, but of red supergiants across the universe. One of the biggest questions surrounding Betelgeuse is how much mass it has lost in recent years. Red supergiants like Betelgeuse lose mass through strong stellar winds and eruptions, but scientists are still unsure exactly how much mass the star has shed. By studying the clouds of material around Betelgeuse, astronomers hope to calculate its mass loss rate, which will help predict when it might explode and how powerful the explosion will be. Finally, Betelgeuse's supernova could provide insights into one of the biggest questions in science: how life begins. The elements created in supernovas, such as carbon, oxygen, and nitrogen, are essential building blocks for life. By studying the explosion of a star like Betelgeuse, scientists can learn more about how these elements are distributed throughout the universe and how they contribute to the formation of planets capable of supporting life, like Earth. Betelgeuse is one of the most prominent stars in the Orion constellation, marking the upper left shoulder of the celestial hunter. Orion is visible in both the northern and southern hemispheres, making Betelgeuse one of the most recognizable stars in the sky. If Betelgeuse were to go supernova, the appearance of this constellation would change dramatically, at least temporarily. This would have cultural and observational significance, as Orion has been used for navigation and storytelling for thousands of years. The absence or bright explosion of Betelgeuse could shift how we view the night sky. One of the most important tools astronomers use to study supernovae is the light curve, which charts how the brightness of the explosion changes over time. When Betelgeuse explodes, its light curve will tell scientists a great deal about the energy of the explosion, the amount of material ejected, and the composition of the star. Light curves can also provide clues about whether Betelgeuse will leave behind a neutron star or a black hole, which are the typical remnants of massive star explosions. Supernovae don't just produce light, they also release gravitational waves, ripples in spacetime caused by the rapid acceleration of massive objects. When Betelgeuse goes supernova, instruments like LIGO, Laser Interferometer Gravitational Wave Observatory, could detect these waves, giving scientists an entirely new way to study the explosion. Gravitational waves would provide insight into the star's core collapse and the formation of the supernova, offering a multidimensional view of the event beyond just light. The material Betelgeuse has already ejected and will eject during its supernova will create vast clouds of dust in space. Studying these dust clouds is crucial because dust plays a key role in the formation of new stars and planets. By analyzing the dust surrounding Betelgeuse, scientists can learn more about the life cycle of cosmic dust, how it forms, and how it interacts with light. This research is essential for understanding both the creation of new solar systems and the evolution of galaxies. Given Betelgeuse's distance and its dimming episodes, One might wonder if we could somehow miss the moment it goes supernova. Fortunately, the answer is no. Even if the explosion starts while Betelgeuse is on the opposite side of the Earth, telescopes around the world and in space are constantly monitoring it. Once it explodes, the light and energy will be so powerful that it will be impossible to miss, even with the naked eye. There are different types of supernovae, and scientists are still speculating which one Betelgeuse will produce. Most likely, it will be a type I supernova, which occurs when a massive star runs out of fuel and collapses under its own gravity. In this type of explosion, the outer layers of the star are violently ejected into space, while the core either becomes a neutron star or collapses into a black hole. Understanding the exact type of supernova could help refine models of stellar death and the mechanics behind these powerful explosions. Supernovae don't explode in an instant, they unfold over a period of time. When Betelgeuse goes supernova, the initial explosion will be visible for weeks or even months. Over time, the brightness will gradually fade, but astronomers will be able to observe the remnants for years or even centuries. The explosion will leave behind a nebula, a cloud of gas and dust that will slowly expand and glow as it interacts with the surrounding space. The Crab Nebula, for example, is the remnant of a supernova that was observed nearly 1,000 years ago. Betelgeuse is a pulsating star, meaning that its size and brightness change over time. These pulsations are caused by complex processes in the star's interior, where energy is transported from the core to the surface. By studying the rhythm of Betelgeuse's pulsations, astronomers can learn more about its internal structure and how energy flows through massive stars. These insights are crucial for predicting when Betelgeuse might go supernova, as changes in its pulsations could be a sign that the explosion is imminent. One of the goals of modern astronomy is to understand what happens inside a star like Betelgeuse right before it explodes. Unfortunately, the core of the star is obscured by layers of gas and dust, making it impossible to see directly. However, the James Webb Space Telescope and other advanced instruments are capable of studying the star's outer layers in detail. By tracking changes in Betelgeuse's temperature, composition, and light output, scientists may be able to infer what's happening deep inside, offering clues about the core's final moments. The explosion of Betelgeuse will release massive amounts of energy and material into space, including heavy elements like carbon, oxygen, and iron. These elements are essential for the formation of new stars and planets, meaning that Betelgeuse's death will contribute to the birth of future celestial bodies. In this way, Betelgeuse's supernova will play a role in shaping the future of our galaxy, continuing the cosmic cycle of life and death that drives the evolution of the universe. Supernovae are one of the most powerful forces in the universe, capable of reshaping entire galaxies. When a star like Betelgeuse explodes, the energy released can trigger the formation of new stars, compressing nearby clouds of gas and dust. Supernovae also help distribute heavy elements throughout space, enriching future star systems. By studying Betelgeuse's supernova, astronomers will gain insights into how these explosions have shaped the Milky Way and other galaxies over billions of years. When Betelgeuse finally explodes, it will be a global event. Astronomers will likely use a combination of scientific journals, press releases, and social media to announce the discovery. Major observable object made of tightly packed neutrons. If Betelgeuse was massive enough, however, it could collapse into a black hole. Either way, this remnant will be a fascinating object for future study, helping scientists understand the extreme physics of collapsed stars. Supernovae don't just produce light and gravitational waves, they also release vast numbers of neutrinos, nearly massless particles that pass through matter without interacting. These neutrinos provide crucial information about the core collapse of a star. When Betelgeuse goes supernova, detectors around the world will capture these neutrinos, giving scientists a unique window into the heart of the explosion. In recent years, computer simulations have become a vital tool for understanding supernovae. By simulating the physics of a star like Betelgeuse, scientists can predict how the explosion will unfold and what kind of remnant it will leave behind. These simulations are based on a combination of theoretical models and observational data, allowing astronomers to test their understanding of stellar physics and refine their predictions for Betelgeuse's eventual supernova. For astronauts aboard the International Space Station or future missions to the Moon or Mars, Betelgeuse's explosion will be a spectacular sight. Without the interference of Earth's atmosphere, the supernova will appear even brighter and more detailed from space. Astronauts will have the unique opportunity to observe the event firsthand, adding a new dimension to human exploration of the cosmos. One of the most important roles of supernovae in the universe is the creation of heavy elements. Elements like iron, which are essential for planets and life, are forged in the intense heat and pressure of a supernova. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.